Okay, so first of all, welcome back. Happy Wednesday. Today is class 4. We are covering linear equations and rational equations in section 1.2. I handed out the first project last class. If you don't have one, you see me right after class and I will give you one. It says here it is due on Friday. I'm going to make an announcement about that in just a couple of minutes. Any questions on the calendar? Okay, so here we are at the top of, I think we're on 17. And I just want to do one part on this page, this multiply and simplify. So this guy right here has a 12 on the outside of some parentheses, and for sure that 12 distributes into the parentheses. So I'm going to write that. 12 times the first fraction, oops, 4, minus 12 times the second fraction. So does everybody buy? That's correct. 12 distributes into the parentheses. Doesn't matter that it's fractions. We understand that's how distributing works. Now, if you wish, you can distribute this 12 on top, because after all, it's really 12 over 1, and we know multiplying fractions, we go straight across. So the bottom is just 1 times 4, unchanged, but the top, you could distribute the 12. But if you do that, you are missing a big opportunity, and this opportunity is sort of a key in this problem. And that's that the 12 and the 4 can reduce right now. 12 and 4 become 3 and 1, right? It's just 12 on top and 4 on the bottom, so they reduce. And the magical thing about this is that the fraction has disappeared. It's not a fraction anymore, right? Because it's an over 1. And the same magical thing happens on the second one. 12 and 3 reduce and become 4 and 1. No fractions left, which is great. So I think we do need to distribute and then we'll combine terms, but the hard part is done here. So this 3 is now distributing through the x plus 2. If it helps, you can imagine parentheses there. So we distribute the 3, we get 3x plus 6 minus, we distribute the 4, 4x minus 4. So far, so good. Anybody have a problem with what I wrote? Big negative? No problems? Yeah. We are going to simplify for sure because we got like terms. This awkward pause that I'm inserting is my way of saying I have made a common error. It should be. Yeah, this is not right here. That's not it. Because this wasn't just a 4 and a negative 1. It was a negative 4 and a negative 1. And at the end of the day, that is a plus. And it is so easy to make that mistake. So I liked Liam's idea of keeping parentheses. If you keep the parentheses, no problems. We will see that that subtraction symbol distributes through the second parentheses. So let's do this in 2 steps and then we'll be done. The first guy really doesn't need the parentheses, but the second guy changes to minus 4x plus 4. And then combine terms, 7x plus 10. I think that's our answer. What did I do wrong? Oh, negative x. Yeah, so the nice thing when I make mistakes on purpose, like I did up above, then I can take mistakes that were clearly not on purpose and say, I meant to do that just to see if you guys are paying attention. So what should it be? Negative x. Thank you. It's great. I'd give myself an out for the entire semester. Any mistake on my part is intentional. All right, I think that's good. Yeah, negative x plus 10. Okay, so part A, I think hopefully was straightforward. What's the answer? Oops. X equals 3. Anybody else get that? Okay, x equals 3 with some careful distributing. Okay, the last part is the tricky part, this solving this equation right here. And we're actually going to do that together on the very next page. So just turn to the next page. The equation at the top here is the same equation that you have on your page. But here's the announcement that I promised. So the project was assigned on Monday and due on Friday, and I just didn't really even realize that there wasn't going to be a weekend in between. And I'm not super comfortable giving students projects without having a weekend in between, because I know some people work weekdays and weekend is the time when most of the schoolwork happens. So our project is now due on Monday, not on Friday. Keep in mind, this project has to do with the computer and using this brand new piece of software called GeoGebra, which most of you have never used before. Please do not wait until Sunday night to discover that you have some technical issue on your laptop and can't get GeoGebra working. I will not have a lot of sympathy if you come to me at 12:45 on Monday afternoon and say, hey, I couldn't get GeoGebra to work. Well, what have you been doing the last 6 days? I've been around, right? So I can help you with it now, and I can help you tomorrow, and I can help you Friday, but I can't really help you Monday at 12:45, okay? One thing you could do, ignoring any laptops or tablets or whatever you have, is just use one of the computers in the math studio. They all have the software already on them, which takes away a piece that is going to be annoying for some of you, and that's the downloading the software. So just go after class or before class, do it in there. Pete.
I'm just wondering if you use a flash drive or whatever on one of these computers, you can like take to any other.
So GeoGebra is a free download, so you're not going to be using a flash drive. You're just going to go to the website to grab the software. But the GeoGebra files, yes, you can transfer with a flash drive, just like a Word file or an Excel file. But get the software. Like, you got to have the software on the machine independent of your flash drive. Okay. Yep. Okay. All right. So let's take a look. Number 1 says, do you agree that it is easier to solve linear equations without fractions? Easier to solve equations without fractions than with. So the question is there a way to solve linear equations that contain fractions without having to deal with them? And the answer happily is yes. And we're going to make our lives simpler by clearing an equation of fractions. So here's the equation. It's the same one that you guys had at the bottom of that page. X plus 1 over 4 equals 1 over 6 plus 2 minus x over 3. That's our start. Our technique here is going to be to multiply both sides of that equation by the same number. That's one of the few things we're allowed to do, right? You can multiply both sides by 7 or negative 53. As long as you do the same thing to both sides, you're good. But you don't want to pick 7 and you don't want to pick negative 53. You want to pick the ideal number, which is going to get rid of all the fractions. And the ideal number is the, anybody know? It is 12 down there, mathematical acronym. LCD is good. Least common denominator. Least common denominator. So we want to look at all of the denominators, in this case 4, 6, and 3, and we want to find the smallest number that they all go into. Smallest thing they all go into. And 12 sounds like the winner. There are bigger numbers. For example, all 3 of these numbers go into 24. They all go into 36, but you want to find the smallest, the lowest common denominator. And in this case, it is 12. Now, there's a little bit of a miracle that happened. Some people just looked at those numbers and were able to figure out the 12. I will show you a way to come up with the 12, even if you can't just look at it and by inspection have that miracle happen. But let's assume that we know the 12. I'm going to take that whole equation, I'm going to copy it in black. And we are going to multiply both sides of that equation by 12. Parentheses around both sides. Okay. And you just got to make sure you're doing things that are algebraically legal, and multiplying both sides by a number, the same number, is one of the things we're allowed to do. So there shouldn't be any mystery. It might not be clear why 12 is helpful to us, but at least it's legal, right? We're doing something that is fair game. Okay, I'm going to copy the left-hand side. 12 x plus 1 over 4. But the right-hand side is where some action is going to happen. What can I do with that 12 on the outside of the big parentheses? We are going to reduce, but I got one more step first. We're going to separate it. In fact, remember the example that we did together, the first one, part A, on the previous page. We distributed a 12, didn't we? Well, let's distribute this 12. So 12 times some stuff plus 12 times some stuff. 1/6 here, 2 minus x over 3 there. Okay, and now Ivy had the right idea. We're going to reduce. The first fraction has a 12 on top and a 4 on the bottom. What do they become? 3 and 1. Great, and we're not going to write the 1 in the next step. And the middle fraction, 12 and 6, become 2 and 1. And the last fraction, 12 and 3, 4 and 1. And in doing all of that, the fractions disappeared. That was the idea. Do you see why 12 is the magic number that's going to make that happen? Because we picked a number that 6, 4, and 3 all go into. We could have multiplied both sides by 10, but then the 10 would not reduce with the 4, at least not all the way down, right? You're picking a number that's going to reduce entirely with all the denominators. So that's why 12 is the winner in this case. Okay, so the rest of this is going to be pretty straightforward. Let's just write it out. 3 is going to distribute, so we go 3x plus 3 equals, the 2 distributes, but it's just 2 times 1, plus the 4 distributes, 8 minus 4x is good. On the previous page, I got in trouble right there at that step, and I made a common mistake. So my question to you is this okay, or have I made that same common mistake as I made before? It's okay only because this is addition. And on the previous page, there was a subtraction problem. So maybe we take Liam's suggestion and just make it like a universal. Anything that was in parentheses before, just keep it in parentheses. In this case, those parentheses are completely extra. They're not necessary. But if that was a subtraction problem, it would be necessary. So how about we just make it part of the routine, put them every time. Better to have them when you don't need them than to not have them when you do. Liam's law. Let's do that. Liam's law. Okay, thank you. Okay, so in this case, we don't need the parentheses, so we will ignore them here. 3x plus 3, and then equals, and then we'll combine terms. I see a 10 minus 4x. Is that right? And then now it's a much more straightforward algebra problem. Again, no fractions. I like getting my x's to be positive, so I'm going to add the 4x to both sides, 7x. And then that 3 is going to go over by subtracting 7. And then divide both sides by the 7. X equals 1. So there's our answer. In theory, you should always be checking these. So that means taking x equals 1 and plugging it into the original equation and making sure the equation is true. You will find with a little bit of work that yes, it is true in this case. I'm not going to do it just because it's annoying and I don't want to do it, but it's all these fractions that you got to play with, and you're not getting rid of the fractions there. You're actually doing calculations with fractions. Okay, any questions on this process? Okay, I mentioned that the 12 was a miracle that many of us had, but in case we didn't have it, I want to be clear there is a way to find that 12 without just looking at it and having the miracle. What were the 3 denominators again? 4, 6, and 3. This is not going to take very much space. I'm just listing my denominators here. I'm going to factor all those denominators as far as I can, meaning all the way down to what kinds of numbers? What are the kinds of numbers that have no factors other than 1 in themselves? Primes. We're going all the way down to the prime numbers. So 4 is really 2 times 2. 6 is really 2 times 3. And 3 is already prime. It's just 3. And so in looking at these denominators, we're just going to make a pass through. I'm going to say, okay, I've got a 2 right there. And so for sure, I need a 2 in my least common denominator. So that 2 is there. And I'm going to keep looking. I'm going to say, okay, I've already got a 2 taken care of in my least common denominator. So this 2 in the middle here, I don't need to throw it again. I've already got a 2. So that 1, 2 takes care of both the circled thing and the checkmarked thing. Okay, and I see no more 2s. That's fine. Another color here. There is a 2 right there. So I'm going to take care of that there. And I'm making a pass looking for things I haven't checked yet. I don't have any more 2s, so we're good there. One more color. I see a 3 here. And that 3 that we just wrote is going to take care of a single 3 in every single number. And what are you doing? So you are adding these guys and getting 12? All right. So if Aaron's method of adding those original factors works, I'm going to be, it does work here. My mind is going to be blown if it works all the time. Yeah, that would be, we got Aaron's law. We got Liam's law and Aaron's law. Yeah, maybe make up another example, and I'm hoping we see it does not work all the time. Yeah. Okay, so there you go. 2 times 2 times 3. That's the lowest common denominator. It's 4. Yeah, that's it. Okay. Yeah, I think that's good. All right, next page. What makes we're just going to skip down here to 4. 4 is another thing that's similar in that it is an equation with fractions in it. But what makes 4 more complicated than the one we just did? We've got x's floating in the denominators. Before, the denominators were just numbers. Now we've got some x's. Fortunately, the technique is the same. But I got to find what the lowest common denominator is. It is very tempting. I'm going to write something over here that is not true. It is very tempting to say, oh, lowest common denominator. I just look and I grab all the denominators I see. There's an x. There's an x squared minus x, right? That is a common denominator. It will work, but you are getting yourself into trouble if you pick one that isn't the lowest common denominator. And you might paint yourself into a corner where we don't have the tools to solve the problem, even though you've done everything legally. So I'm going to put a line through this because this is not the lowest common denominator. So here's how we find it. Plus 1 over. We want to factor. Just like we factored the number 4 and the number 6 all the way down, we're going to factor these denominators all the way down too. First kind of factoring to look for, I'm looking at this guy, is the greatest common factor. We're going to pull it out front. What is it? X. Go ahead and fill in the blank parentheses there. Factoring out that x. So what do we get left over? X minus 1. And then equals the 5. We just copy that there. Okay, now we're going to write the actual lowest common denominator. What is it? X minus 1 for sure is in the lowest common denominator. X for sure is in the lowest common denominator. Question is, do I need the other x? Like, I've got this x, I've got this x minus 1. Yeah, the first x that we've written over there in blue is going to knock this guy out. Just imagine taking this thing right here and multiplying it right here. Can you visualize that the x that we're bringing over is just going to cancel with this green x in the bottom? We see it? We don't need another x over there in that lowest common denominator. We've got our winner. Okay, so technique, as we've seen, is to multiply both sides by the lowest common denominator. So here we go. Big parentheses here, x times x minus 1. Big parentheses here, x times x minus 1. This problem involves a lot of copying. It's possible to kind of do a little shortcut and do 2 steps in one with some stuff in your head, but I just find it leads to more problems than it's worth. So we're going to do a lot of copying. This thing right here is going to come in and distribute. So it's about to get bigger, but then it'll get smaller. So x minus 1 times, what's the first fraction? 1 over x. That's the first distributing. Plus the same x minus 1 coming into the second fraction. What's the second fraction? Good. Equals, and then just copying the right-hand side. So mildly annoying to write all that out, but leads to a lot more accuracy. So let's start canceling. What cancels in this first term? Just the x. So x there, x there. What cancels in the second term? Everything. Oh, goodness. X minus 1, all of that. Right-hand side had no fractions. There's no canceling to be done. So we're good to go. We just have to carefully do our multiplication here. So we're doing x minus 1, distributing that 1 into it. It's just x minus 1 plus second fraction plus 1 equals third fraction. In my mind, this is a single 5x, which is getting distributed. So what do you get? 5x squared minus 5x. That's good. Okay, we did not follow Liam's law. What should we put throughout? What should we be putting? Parentheses. So anything, any single term from before, it will still treat it like a single term. Again, did the parentheses matter here? Not in this one because it's plus. But we're not going to get it wrong by putting extra parentheses. Just put them every time. Okay, so now we'll combine terms here. So on the left-hand side, the minus 1 plus 1 cancels. Now this equation is more complicated than any of the earlier ones we did today. How do we solve this? Add 5x? Yeah, there's nothing wrong with moving the 5x to the left. It's legal, but you got to think about like the big picture. Like what is the technique for this equation? Yeah, Jed. Yeah, why? Yeah, like the right-hand side is a quadratic, right? It's got that x squared in it. And you guys know that the way you solve many quadratic equations is to get one side to 0. And so that's the idea. So we're going to subtract the x, which leaves us with a 0. So subtracting x makes a minus 6x. And then I think Jed also saw the next step, which was to factor the right-hand side. What can you factor out of both? X comes out. Go ahead and fill in the parentheses. So what's left, I think, is a 5x minus 6. Is that right? Okay. And then this is the part where we split into two simpler equations, right? So either, I'll do the second equation first. Either 5x minus 6 is 0, right? Or, what's the other equation? We're going to solve that in a second, but the other equation is x equals 0, right? We had the two, this one, and we had this one. And either of them could be 0. So we got to solve those two equations. First equation is done already. X equals 0 is the solution. And the second equation, add 6 and then divide by the 5. 6 over 5 is good. Phew. Yeah, these fraction equations are no joke. You want to know the bad news? Is that even though we've done everything correctly, one of those two numbers up there is a lie. And this isn't me lying on purpose just to see if you guys are on your toes. This is, we did everything right. And it's just a fact of life with these fraction equations is that sometimes one or more of the answers are lies, which makes it all the more important to check your answers. It's just absolutely mandatory. I know you've been trained in a lot of algebra classes, always check your answers. It's just to like give you practice, but like here, literally you have to check your answers because you're not looking for mistakes necessarily, you're looking for lies. It's not your fault, but one of these is not working. If you take x equals 0 and go all the way back to this original, it's kind of written over here. I'll go back here. If we take x equals 0 and we plug it in, no, it's not there. Sorry. This guy up here. If we take x equals 0 and we plug it in right there, and also just for kicks, there, what do you get in the denominator? 0. That's no good, right? You've known you're not supposed to divide by 0 for a long time now. So x equals 0 simply does not work, even though we made no errors along the way. It just happens with these fraction equations. Sometimes you get what we call extraneous solutions, extra solutions. So x equals 0 needs to get rejected. What was the other one? 6/5 or 5/6? 6/5. Okay, so if you plug in x equals 6/5 for that x and that x and that x, and you do a whole lot of annoying work with the fractions, you will see that the left-hand side turns out to be 5. So 6/5 is going to work. Here's the good news, the only piece of good news for this problem. You don't actually have to do the entire check. Do you guys see how annoying it would do to do the 6/5? How annoying it would be to try to check 6/5? I'll just write the first step because it's so annoying I don't want to do it. But just so that we're clear on how annoying it is, right? 1 over 6/5 squared minus 6/5 equals, I'll put a question mark because I don't know if it's going to work. This is what you have to check, right? Look at all of the fraction work involved. You have to square 6/5. You have to combine the fractions on the bottom, but they won't have the same denominator in a second, so you need a lowest common denominator. And then at the end of the day, you're still going to have stuff like this, where it's a fraction within a fraction, which needs to be cleaned up. But if you do all of that, trust me, it will turn out to be 5. And the reason that I know it's going to work isn't because I've done all this in my head. It's because the only thing that would make the answer not work is if you have division by 0. And I can see just by looking right here, that is not a division by 0. This is likewise not going to be a 0. That's all that I need to feel comfortable that it is going to work. Okay? So check is mandatory, but all you are looking for is whether or not you have division by 0. Okay? Okay. Last piece of this puzzle. Okay, so let's come down here. This guy gets rejected. Reject x equals 0. And some books, and I think also my math lab, are going to ask you for this phrase here, excluded values for x. One of them is what we just found. X equals 0 is one of the excluded values. And we could have known that just by looking at the equation originally. Just seeing that x in the denominator, 0 is a problem. There's actually another problem from the other equation. X squared minus x. If it happened to equal 0, that would be a problem, because that would mean divide by 0. Well, this is just a whole brand new equation to solve. Jed's technique is going to work for us here too. 0 on one side, that's groovy. What do we do on the left-hand side? You could add the x, but I actually really like having the 0 there. We can factor an x out on the left-hand side, and if you do that, then you split it again. X equals 0 is the one we've already seen. How much, what value of x makes the parentheses equal to 0? Is 1. And so the excluded values of x are 0 and 1. Just imagine if you had gotten x equals 1 as the answer, what would happen when you plugged in 1 for both x's here? 1 squared minus 1 is 0. So that's what you are finding, right? So it's just like automatically part of the process. Just set the denominators equal to 0 and know ahead of time if you get any of those numbers, you reject them. Okay? Okay. So the activity starts on the next page. I just want to spend another, 2 minutes on this one problem. This is tough stuff. If you took Math 096 here at GCC, that's the intermediate algebra class. This was the very last lesson of the entire semester. In some sense, the conclusion, right, the culmination of a whole semester's worth of intermediate algebra. Not easy. I can tell you that some of the teachers teaching 096 here didn't solve these equations in the way that I just showed you. So I'm going to show you the other way just in case. I want to know who I'm talking to. How many people took 096 here? All right, so it's almost all of us actually. And even if you didn't, maybe you'll prefer this other way to the way that we just showed here. So alternative. Okay, I don't know if you have space on this page to write what we're about to. See if you can find some blank space someplace. So here's the alternative. I need someone to read me the original.
1 divided by 1 over x
Yeah.
plus 1 over x squared minus x.
Thank you. Okay, so there's our original. So again, what we're about to do hopefully will look familiar for folks who did 096 here. Okay, I'm going to copy that first fraction. I'm going to make the fraction line a little bit longer. There's going to be some stuff going into the blank space there. Plus, I'm going to copy the second fraction, but factor that denominator, which is something that we've done before. Move this up a little bit. Factoring x out of that denominator. What goes in the parentheses? X minus 1. It's good. Equals. And then this 5 is about to get its own fraction. So just a big blank fraction line. We'll fill them in. So step 1 is factor all the denominators. In this case, there was only one thing that needed factoring. Step 2 is to make these blank fraction lines. Step 3 is to make the fractions all have the same denominator, all have that lowest common denominator. And we're going to do that with this technique that I think of as filling in what's missing. The first denominator has an x. What does it not have that the second denominator does have? X minus 1. So how about we multiply the bottom by x minus 1 and then say, hey, look at those first two denominators. What do you notice? They're the same. That's great. My goal is to make all the denominators the same. But I can't go around randomly multiplying the bottom of fractions by x minus 1 without immediately doing what? Same on the top. Right? There's lots of rules in algebra. One of the things we're allowed to do is multiply top and bottom by the same thing. Doesn't matter what it is. As long as it's the same, you're good to go. We had a silly acronym for top and bottom the same. Anybody from an 096 class? First letter was F.
Foil?
Not foil. Anybody remember foo-foos from 096? Right? Yeah. I'll write it here. It doesn't really look the way we pronounce it. Fancy form of 1. Fancy form of 1. This thing in purple, x minus 1 over x minus 1. What is it equal to? It's 1. It is just a fancy form of 1. Foo-foo. Okay, so first denominator is now complete. Second denominator, this is just coincidence. It's already complete. We don't need anything. But I could imagine I'll put something and then I'll erase it. Like if this guy right here had a 7, then this is the part where we'd say, oh, the second guy, what is it missing? 7. So give it a 7 on the bottom, and then at the same moment, a 7 on the top. What do you see about those two denominators? They're exactly the same. So still got that lonely old 5 there. The 5 has nothing in the denominator. It needs everything. So it needs a full copy of either of these denominators, which at this point are exactly the same. So in purple, we will give it both x and x minus 1. But what do I need to do at that same exact moment? Same thing in the numerator, x minus 1. Okay, here is the key. This is the part that looks like magic for some students who don't really think about what's going on. Suppose that I had two fractions. 7/4 equals some number over 4. What is the question mark? For sure it's 7, right? Easy. What made this easy is that the 4s were the same. If I had made this a 5, now there's work to do, right? It's not obvious what that question mark is. You can figure it out, but it's not obvious. But if the denominators are the same and the fractions are equal, then the numerators have to be the same, right? It's obvious in this case. These denominators are all the same. And if they're all the same, then the numerators have to all be the same, which means that with one fell swoop, I'm going to cross off all of those denominators. and say, hey, the numerators have to all be the same. The only reason I could do that is because we did all the work to make the denominators the same. We made the fourths on both sides. And now we've done the hard work, we can ignore it. Ignore the denominators, they're all the same. Technically, what we're doing mathematically is multiplying both sides by x and x minus 1. And then it cancels with each fraction. Okay, we're not going to do any more on this because I'm pretty sure we wrote exactly this line up above. I don't know if you can find it, but you should see like a 1 times an x minus 1 plus, let's see if I can find it here. Looks to me like it's this line. 1 times x minus 1 plus, there's just a 1 left over, equals 5x x minus 1. That's exactly what we have down there. I'm not saying it's any better because you still have the rest of the process and it still becomes a quadratic that needs factoring and you still need to check your solutions. I'm just giving you an alternative to get to the star. So last semester, if you took 096, you probably did it this way, where you filled the denominators in to make them the same and then you ignore them. Perfectly good option. Another one is what we did today. Multiply both sides by the lowest common denominator. Your preference, okay? Fraction stuff is hard, and that's when the fractions have numbers in them. Fraction stuff with x's is even harder. So this is not an easy section. Okay, the activities start on the next page. I will walk around and help